over to you.
Okay, so let's try and do that. So you probably all saw the agenda of tonight, and it has nothing to do with what's going to happen. That was the right. We lured you. It's called bait and switch. But in bait and switch, when we bait you and then switch, it's usually switch to something that is worse than the original. This is a very sick bait and switch. It actually shifts for the better. Right? What I want to talk to you about is supply chain security. And after, I will share with you some insight from the amazing job that our security team does in JFrog. Maharashi is going to show you what we can do about all the problems that we're going to talk to you about. Now, the thing is, the first talk was supposed to be like the state of software delivery something, and I can do this talk in one sentence. The state of software delivery in 2022 is shit. That's the end of first talk. Now let's get to the next one. And that's a little bit details about why. So, you can see here a Google thread or Google trend of the interest in software supply chain. It goes like, no one cares about it, no one really cares about it, and then boom, people start caring about it. What happened? Why? Why would people suddenly be interested in an obscure topic of software supply chain? Because hacking is expensive. What? Why? What it has to do anything? There is a company which is called Zerodium.com. Those guys pay money for exploits. If you find an exploit, you can use it for doing something bad. You can try and beg companies who are in charge of those exploits to give you money for exposure, or you can go to those folks and sell the exploit to them. They will negotiate with whoever can do something about it, and will probably make a lot of money of being a middleman. But what's interesting is how much they pay. Now, zero-click root escalation. What does it mean? It means it's a hack that you get a root privileges on desktop and server or on mobile. How much can you get for such an exploit? Well, $1 million for a desktop and $2.5 million on a mobile. What does it tell you? It's hard. It's almost impossible today finding this exploit. And all of them are extremely hard. Like Chrome root escalation, $500,000. Right? iOS, $2 million. WhatsApp, $1.5 million. Today's hacking is very, very hard because it's been a while. People know what they're doing. Their software is good. But you know what? You don't need to anymore. Turns out that most of the software that most of the people use in whatever they write, it's not theirs. Right? 17% of code in code bases is open source in 2020. 80% of the code that you have in your application is not even yours. And that means that you don't know the quality. And if you don't know the quality, it means that this can be a very, very easy target to hack comparing to traditional hacking that is now very hard. And this is great for hackers because it means that they can achieve the same, well, not exactly the same. I'm going to talk to you about it in a second, but pretty much the same in much less effort by hacking the supply chain instead of trying and hack your operating system, your or your software. So yeah, as Narwas already introduced me, my name is Baruch Sadogurski. This is my official business card. One of the perks of being very early employee, I can name myself as a chief sticker officer. We have stickers. We have stickers. We might have stickers. That's a good answer. We might have stickers. So if we don't, that's me to blame. If we do, that's thanks to my dad. Because it's my responsibility as chief sticker officer. Also, I'm a principal developer advocate as JFrog, and on this part of my job, I'm going to tell you stories about how awesome other people in JFrog are. And this particular moment, our researching is that they are. The most important part on this slide is, except of the awesome sticker, of course, of the Bedfrog, is my Twitter handle. This is the simplest way to get to it. Right, couple of things to know. JBaruch on Twitter, already mentioned. JFrog X-Ray, that will be kind of the hashtag if you want to share something about today. And then if you go to jbaruch/show notes, you can find the slides already there, the video. Hopefully I didn't fuck anything up, so we will have the recording. Maybe swearing is not, okay, never mind, too late. And that means that you shouldn't really like take any pictures or write anything down, because this is how it will appear on each and every slide of this talk, so you can always go there and see what you want to see. So anyway, I'm going to go here. As I mentioned, most of the knowledge here is not mine, so it's all written down here. I'm going to sneak peek in order to know what I'm talking about. Right, so supply chain threats. There are 3 types of supply chain threats. 2 of them based on software vulnerabilities. It means something did something wrong within an existing particular software, intended or unintended. And the third is purely malicious. It means that this software came to be in order to do something nasty, right? So bugs, those are the unintentional vulnerabilities. Right? People make mistake and now their software is vulnerable. This particular version of the software, today's version, yesterday's was fine, tomorrow they're going to fix it, it will be fine as well. Today there is a bug. The other one is backdoor. Also, backdoor is a vulnerability. Either someone did it on purpose inside this software, inside this package, or maybe someone managed to hack it and insert a backdoor for this particular version of totally innocent software as it was yesterday, and it will be tomorrow. For those types of vulnerabilities, we have the CVE identifiers, which identify this particular version of software as vulnerable. Log4j version X has this bug. Version Log4j X.1 doesn't have this bug anymore. We have a CVE that points to version X. The third one is the most interesting, and those are malicious packages. They don't have vulnerability identifiers because it's not that they're vulnerable for something. No, they behave as expected by doing something bad. And those are the most dangerous ones because from a traditional view of software security industry, there is nothing wrong with them. There is no bug, no one attacked them, nobody exploited them. They actually do what they're supposed to do, and that being bad. So this is interesting, and we're going to talk about all 3 of them today. Right? So Log4j is the example, as I already mentioned, of the first type. There was a bug. Now, it's even more interesting. It's not even a bug. How familiar are you with what happened with Log4j? Yeah, all right, I'll explain. It's very simple. Log4j is a logging library that allows you to log what happens in the system. Now, it's very flexible. You can control what is being printed, how it's being printed, and where and what it uses to be printed. One of the clever things that the authors did is the ability to load additional functionality of logging on the fly by using Java's hot class loading functionality. And there was a format that you can say, hey, I'm going to bring more classes to my system in order to do logging more successfully. Turns out that bringing classes and loading them on the fly is not a very secure idea. Who can imagine? And indeed, no one could imagine for years. This functionality has been in Log4j for years. Nobody thought to explore, oh, come on, what is this word? Exploit, thank you. To exploit it until someone actually had. And this, all the internet got like exploded about. But it was a feature, it was by design. Nevertheless, it was considered a vulnerability, a bug. It was fixed in the next version, and this is why that's the first time. That's the first time. That's a security bug. SolarWinds. SolarWinds is an example of the second, of a backdoor, right? So it's an intentional bug, if you wish, right? So it was attacked, and then a backdoor was injected in it. And again, we had a version of the software that was attacked, CV, etc. This is an example of the third one. This is just a package that was created to steal credit cards. This is what it did. They obviously didn't declare it. They pretended it's something else, but the whole purpose of this package was stealing credit cards, and it didn't even get CVE because it's not a vulnerability, really, right? So let's talk about injection methods. How vulnerabilities are injected to your supply chain. The first one is called typo squatting, or there are different types of squatting. Typo squatting means we create a package and we hope that people will confuse it because the name sounds a lot like other packages' names. Here is an example. Mplotlab with an O really looks a lot like Mplotlab with an A. That's the malicious package, right? So if you typed pip install Mplotlab instead of Mplotlab, you got a malicious package. Another one, very similar, called masquerading. Masquerading is actually a little bit more advanced. It not only hopes that you will make a typo, after you make this typo, it actually convinces you that you found the right package. Here's an example of mark.js. This is how mark.js really looks like. This is how the masquerading package looks like. It's exactly the same README. It's exactly the same. It actually points to the same GitHub repository as the original, right? All the metadata is exactly the same. The name is the same. So who can tell me how do you see what's wrong? What's not the same? So here are they. That's the masqueraded one, and that's the original one. What's the difference? That is very, very
npm install. The npm is like the install command is different.
Oh, obviously the install command has to be different because they want you to install the bad one. But how do you know which one is bad? Exactly. The downloads, right? The weekly downloads is completely different. How hard it is to actually fake weekly downloads? What do you need for that? Like a script that hits it at... No, they didn't even bother. This brings me to an interesting off topic. They didn't bother because they are not really sophisticated. One of the interesting aspects that we see in those supply chain attacks, that the attacks are very much naive. The only reason that they are so successful is because those are early days. Even the stupidest things like this one actually work. So you don't have to spend time equivalent to $1 million in order to hack someone, and this is why they don't. Now, it also means that today the attack go for breadth instead of depth. Right? You can do the stupidest thing and still get 10 people with downloading it. And you know what? If your package does something which all it requires, it's a lot of people to download it, like stealing credit cards, or we'll see what. That might be enough. Is it enough? Can you stage this kind of attack to attack a specific individual or a specific organization, or fish for a very specific type of data that you need? Probably not. Right? For that you need a completely entirely different set of skills that those folks, thankfully, still don't have. So the attacks are naive, but they are usually enough to get enough for them to be worth. Okay, so yeah, that's, by the way, the malicious package, the mark.js compared to like a regular one. They actually obviously took all the code because it should work. And then there is one function with obfuscated JavaScript that does what it does. We're going to talk about obfuscation a little bit later. Another injection technique is Trojan package. And this is fully functional and useful library that also does something better. Discord utilities, they do its useful, or let's say, its working set of Discord utilities, which, by the way, also steals Discord tokens. Right? So, again, there is stuff which is completely fine, but there is also some stuff that sends the Discord token of the current user to the owner of this library. Another technique is called shadowing, namespace shadowing. Now, you might have heard this one by the name dependency confusion. I find this name very confusing because everything can be confusion. Namespace shadowing actually describes it a little bit better. Here's how it works. First of all, you have to have a package manager, a dependency manager, like, or something like Artifactory, JFrog Artifactory, or any other. Nexus, anyone you take, actually they all behave the same in order to execute. Because this attack actually uses a very important feature of what we call a virtual repository, or in the case of Nexus, it's called a proxy repository, and there are different names, in order to work. The way it works is that if you have a virtual repository that actually unifies or combines a set of local and remote repositories into a single URL that then you use, this is where you can try an attack. So let's say you have a library that has a version 1.6 out there. And you have a bunch of different versions. 1.6, 1.4, 1.1, 1.2, 1.3, and whatever. And then your tool asks for the latest version. What Artifactory will do, it will check for the higher version of in all the local repositories. And then it will go and check the central repository for maybe there is a newer version. It will find it, and then this is the version that will be served. Now, is there something wrong with this logic? No, this is how it should work. That's exactly how it should work. How it can be used for an attack? If the attacker managed to put here a version which is higher than what you have, then this version will be downloaded. Now, there are obviously a lot of techniques how to protect, and I will show you one of them in a second, but you can see or identify this package by a ridiculously high version. Right? It has a ridiculously high version because it tries to be higher than every possible version that you might have. Right? And the way we can protect it here is, and here's an example of X-ray actually finding it and again like ridiculously high version. That when it first made splash like more than a year ago in February last year, I blogged about it and explained how Artifactory actually protects you against it if you go ahead and do some precautions. For example, you mark your private repositories as priority resolution, and then you say, for whatever comes from this repository, never check for a higher version in public repository. You can also do it with exclusive patterns. Whatever starts with com.jfrog, in our example, never check for in public repositories. This is our internal packages. Even if someone tries to hack us and publishes a package with a higher version, don't check there. It's probably fake. It's not ours, right? So there are simple ways to overcome it, but still. Right, another one is hijacking. Now, hijacking works by hijacking the user or the namespace of a certain package in a central repository, right? So here, for example, a very popular JavaScript library that was hijacked by hijacking an NPM account. How can you hijack an NPM account? Well, for example, you can look for expired domains. Domain expired, that means that you can go ahead and register it, then connect it to your email account and ask for a password reset from NPM registry. You will get a link to reset the password to your email, which is connected to the domain that you just purchased. You can log in, and you can release a new version of the same library with your malicious code. GitHub protects it by forcing it using two-factor authentication. NPM registry does not. Completely different type of attack is protestware. Now, protestware is something that we only recently kind of discovered, and it comes in a couple of different ways, right? So the first one that you might have heard about was Colors.js. Colors.js added Colors.js colorize text in the console for NPM packages, and it added some module that just created an infinite loop, and that was a protest of the author against not being paid for their open source work. they were upset that all the wealthy corporations used their package and they were never compensated for it. So it just made their package unuseful. Right. So another one is Node IPC. Node IPC was another example of protest where there was a political protest against the war that Russia wages against Ukraine. So the author of this package checked the IP of whoever tried to use their package, and if the IP was Russian, they printed a bunch of blue and yellow hearts in the console, represent like Ukrainian flag, but deleted files on the local operating system in the background. Let's talk about payloads. Let's talk about after the package was hijacked or introduced in one way or another, what do they try to do? The first one is very boring, stealing. Stealing credit cards, right? Stealing passwords. This one goes to Chrome default and then select from credit cards of the database of your local Chrome browser. Same passwords from your Microsoft Edge browser, select from logins, trying to find logins. This one, this again, and we already spoke about it, Discord tokens. I don't know what's going on with, you remember how we spoke about naive type of attacks? It turns out that one of the most important things that those folks are after are Discord logins and Discord like login data. Why? There are a number of reasons. Some of them are spamming using other people's accounts. The other are trying to find conversations that they can inject themselves to and this kind of stuff. But I mean, pretty naive, I would say. Yeah, so you can see here a lot of that. Sending the information back to the servers, right? So you can see here, receive shell command string and then sending them back to the server that was originally. Another type of payload is download and execute. And download and execute, the most popular type of software that is downloaded and executed are crypto miners. We spoke about how they aim for breadth instead of being narrow attack. You don't care what computers of whom are mining the crypto for it, right? So that's another type of that. And it's as naive as opening, as like running shells that will download a crypto miner on your computer and just start executing it. Last thing that I want to talk about is obfuscation. How they try to hide what they injected into those packages. First of all, one obfuscated function or a method inside a package is suspicious by itself. All the code is open source, it's right there for everybody to read, and then boom, an obfuscated method, an obfuscated function. This by itself is kind of fishy, and it smells bad, but still people use it. And the obfuscation methods are also pretty much very naive. This one is just encodes everything in base 64. I mean, that's not very hard obfuscation to break. but it is what it is. Another one, a little bit more complicated, but also pretty naive, is trying to confuse the flow of the system so it will be harder to understand when you look at it. Not that someone after their university degree ever tries to comprehend the flow of software by just staring at it. Like, we will use the IDE, we will follow the flow. So I'm not sure how that helps, but again, so instead of this code, they write this, and for some reason that should be for us harder to crack. Those are interesting, using Unicode characters that look the same but actually different, right? So you can see here how this say hello is different than this say hello, because this H is actually a Russian N, which looks like H. Again, the only people who can get confused is who just stare at the code. Even here, you can see by syntax highlighting that this doesn't look like this one. And obviously, we can follow the flow of the system and see that it's not going there. This is also very interesting. Again, using Unicode symbols. It looks like this if actually is there and it's working, but actually it's not. It's a part of the comment. The end of the comment is moved by using a Unicode control sequences that move it to the right, because it actually instructs it to look at this code instead of left to right, from right to left. Again, I mean, how naive is that? That's Java for you, but it's the same idea, right? It looks like all this is a comment, but actually this sequence ends the comment. Then you have a method that does something, it prints a, like a cigarette or something, and then this sequence actually opens another comment, and this one ends it. So yes, if you paste it in your Visual Studio Code that just do syntax highlighting and doesn't do like analysis, you might miss it, but everything more complicated with that will actually see it right away. And also, for our tools that try and find those vulnerabilities, this looks suspicious as fuck. Anyway, how do we detect those? So there are a number of things that you can do in order to be safe. The first is SBOM. Software Bill of Materials is a list of everything that goes into your software. Yes, whatever 78% of the code that is your software is not yours, but it doesn't mean that you have no idea what is there. You actually know, especially if you use software like JFrog Artifactory and JFrog pipelines. They create this SBOM for you. It will be called the build info. In our terminology, in the end of the day, you know what software there is there. Once you know what software there is there, you can go ahead and check if this software has vulnerabilities. How can you check? For example, you can go to the central repositories and check whether they have information that those packages are problematic. Now, unfortunately, central repositories are not very good in providing you with this information. For example, the central Python repository will just delete the malicious packages. You won't know that there is a problem, you will just know that it's not there. And the registry also removes the package with a code that says security holding this package, and you will get some dummy package instead. This is also not very helpful. You don't know which versions actually bad. You don't know if the version that you use was before this package was hacked, and maybe it's completely safe. You don't have this information. So central registries are a nice start, but not enough. You know what is enough? Yeah, and obviously there is another problem that I mentioned in the beginning. Some malicious packages are not vulnerabilities. So if you scan them to actually find vulnerabilities, they will tell you there are no vulnerabilities, and in audit everything is great. But you actually use a malicious package, it's just not a vulnerability. It was designed to be malicious, and you accidentally start using it because of masquerading, because of typo squatting, or because it was hijacked. None of that is malicious, right? So how can you fix it? Rashi is going to show you how we're going to fix it, and that basically JFrog and specifically JFrog.
Absolutely.
All right?
Right. Yeah. So at JFrog, we always believe security has to be part of each and every step that we have in our SDLC life cycle, right? So what we see traditionally is, okay, your security team comes in when we do a build. Now it's in the QS hand, QA testing. Then next we do a security scan. Right now, think of that. We are working on towards like very tight timeline, right? So we have a release that is coming on Friday, right? And now my security team saying that, hey, we cannot release it because it has 10 critical, 5 medium, or 20 lows, right? We cannot do it. So now we are going back to a development team and say, hey, let's go and fix it. But now what we want to do is how I can make my developers is more efficient or empower with the information that I'm sharing, which I'm giving them right after builds, right? So what we're gonna do, we're gonna see this information right there in our IDEs, right? So there is an IDE plugin for IntelliJ, Eclipse, VS, we have NPM, Python, NuGet, Go, we can see the same data. What we are looking at, a plugin called JFrog, it's a free plugin. If you have 100 developers, 1,000 developers, they all can download it, okay? Once you have X-ray, configure against your your artifact instance, and this is where what I'm seeing is my package.
You can do, remember, you can do this. This is very cool.
Perfect. There we go. All right. So what we are looking at here is for my Maven, I see I have log4j, right? Known one. And now on the right side, what I can do is look at click on the log4j. I'm seeing all the CVEs on the right. I'm also seeing the license associated with it. So now if I'm seeing GPL, probably I should now switch something else because my legal team doesn't like it, me using GPL. All right. So what I'm looking is, okay, it has a remediation version. So now if I'm a developer, I see this data, I can simply go here, update the version. Let's go to the latest version, which says 2.17.1. All right. Let's do a save, rebuild it locally. At this time, I have not pushed my code to a version control yet. It's even happening prior to that as well. So now, if we are looking here, log4j is green, right? There is no known CVE. I can also see if I have a dependency, for example, let's say Apache Strut. I can click on it, I can see dependency. Where is the vulnerability actually coming from? So it gives me more like a kind of a deep dive view of that open source library that I'm kind of pulling in into my first party code base. Right? So that's the first skill. Now, for example, let's say you have a developer who is using Atom, right? So Atom, we don't have a plugin. How they can do a scan, right? They can use JFrog CLI. It's a very simple command that they need to do as long as they have terminal. What we are looking is, I go to my terminal, I do JF audit. Okay, if it's a Docker, I can also do a JF Docker scan. I can scan it and just hit enter. You can see here it's pretty much doing build, it's doing a scan as well, and it's going to show me the exactly same data that I'm seeing as part of my IDE level, like the plugin use. Okay, so this is something we can do from any terminal window that we have. Now for the Docker, does developer do a Docker build locally? Yes, they do, right? They do, but they want us to do a scan. One way, you can use JFrog CLI for that. The other way, there is a Docker desktop application that, or Docker desktop that we have, and there is an extension called JFrog. So now, all the Docker images that I have on my local machine, I can switch, I can see the scan results, I can see exactly same data. So now, my developer cannot say, hey, we missed it, right? If they have this information, they can see it, they can fix it at the first time, all right? Now, as they are using Artifactory as their kind of resolution repository, what they can do is, in X-Ray, as a security team, I can go and say, hey, if you find it critical, do not resolve that request. So now, if developer is trying to download log4j 2.10, it doesn't resolve from Artifactory. So now we are not resolving those requests, so now they are not allowed to use it, right? So you can do curation process in between as well if you want, all right? So this is the IDE level. What's next? That's a developer coming to the code, okay? They are not using IDE. What happens, right? So version control, right? So whenever you open a pull request, you can trigger a scan in X-Ray. So now whoever is reviewing my pull request, they can see the scan results as part of my PR. If it's a clean, it's good. If it's not clean, they can see it as a critical vulnerability. Then it's up to them, do they want to merge it or not, right? Most likely not, right? So that's the second gate. Now third gate comes as a build gate, right? You can say, hey, if we found a critical vulnerability, I want to fail that build. Okay, so you can do those kind of things as well. Now, everything looks good. X-ray, pass it tomorrow. Let's say log4j is now vulnerable. We can do the same build. We can block it, notify someone, etc. Those things, all configurable. Okay. Now, what we want to see on today's kind of session is more on how the data looks like. How can get into a JFrog platform and kind of see this information. So, what we are looking here is basically a security and compliance and the scanners. I have my repositories being scanned. It can be my local first-party code, or it can be a remote which I use for downloading open source library. I can do a scan on those requests. I can do the same thing for builds. So the build that I'm scanning is, let's say, which is actually creating a Docker image, right? And what we are looking here is, let's say, one of the build that I have. Let me just refresh. Right, let me switch to the different view or look at the same data. Build 115, right? So it found a critical vulnerability in that. I click here. What I'm seeing is basically what has been published. So Docker image has been published. I can take a look here as well, every layer that I have, right? I can see, I can go to a specific layer and kind of find a checksum, kind of see how it's being used, where it's being used, right? So this is where we go to a build, and this is where I can see kind of where it's, who published it, right? Which build pipeline published it. If I have a assessor, like let's say this specific layer has been used by all these pipelines, right? I can see those data, right? And this is where, when we talk about full audit trail, I can see right there in Artifactory. And this is where, if I go back here, on the build side, X-ray is actually showing me three main things right now. First, what are the vulnerabilities that I have? Second, what are the compliance issues that I can have? And the third and most important, as Parv mentioned, 78% open source. Out of that 78%, most likely 55% or 60% is outdated, right? We write a code, we let it run because it's working fine. We never go and update it, right? And this is where what we are looking at is called operational risk. So now, start with the vulnerabilities. What we are looking here is for Spring Framework, WebMVC. What we are looking here is there are a bunch of CVEs, and out of those CVEs there is a green icon next to it. What it means is JFrog research team looked into those CVEs and kind of provide all the information that we found. Now, when we look at this particular CVEs, let's start with what it's coming from NVD database, National Vulnerability Database. What we are looking here is pretty much 10,000 feet high level information. If you share this with your developer, they will say, okay, what should I do? Am I being kind of impacted? Like, okay, I'm impacted, but how can I fix it? So they have no clue. Okay, this is good for security teams to understand, but for developers it's hard to consume. All right, and this is where JFrog Research Tab comes in. It provides you exactly information which methods are vulnerable. It also tells us how can we remediate as well, right? So do this, right? So this is where developers kind of do a more productive approach, right? So they can know what they need to fix it, how they remediate it, okay? one of the interesting part about this impact analysis, right? And this is where we can see exactly where it's coming from. Remember the ID that I showed you, the dependency? This is what it is, right? So it's actually part of my Maven. That package is part of my jar. Jar was part of the Docker layer, and the Docker layer is part of the Docker layer. So you can see if it's 5 layers deep or 20 layers deep, doesn't matter. As long as actually know the package type, it goes and scans it. Another good example that we would like to kind of go over is called faster XML. Okay, and this is where things becomes interesting. So what we are looking is true severity. One severity is given by NVD, which is critical. The other severity is given by JFrog research team, which is called medium. We provide a reason why we think it's a medium, right? We also tell you the remediation, what to do and all, right? So this is where you can see data, right? Now everyone can understand looking at it. Your security team understand how it's being utilized, or your developers can understand how it's being impacted, right? So that's one part. The second part, compliance. And this is where legal team comes in, right? If you want to allow them, your developers, to use GPL or not, you write a policy, you can discover what are the licenses are being utilized, which are the unknown licenses are there as well. The third, operational risk. And this is where you can see here, for Tomcat version that I'm using, the last commit happened in 2016. There is no active maintainers, so I know there might be security issues, performance issues, but has not been registered. And this is where I have this information. If we have legacy system or APIs that we have written, or just kind of it's working fine, we forget it. That's where how we get it. Now, creating SBOM data. How simple is it? It's right there. So I can go and click here, export into SPDX, DX format, and this is where I share with the customers that I have, right? And kind of they can kind of feel confident, right? So those are the things. Now there are new scanners coming in X-ray, and those scanners are basically same view, right? We are looking at the scan list, right? And this is where we are talking about container scanning as well as Terraform scanning. All right, so let's start with the container. So for first container, let's say SBOM generation is right there. When I go here, vulnerabilities is exactly the same what we saw previously, right? What are my CVs and how it's there, right? Now it also offers the kind of filter or make a UI chain, what is kind of interest to you and all. You can also do, okay, let me see this column called contextual analysis. What contextual analysis means, because we know the runtime, is that CV is actually applicable to you or not, right? And that's where we talk about false positive, right? Not every CV is applicable to you directly or not, right? And this is where you can see here, bunch of CVs there. Out of that, this is actually applicable to me. So you can see those level of information. Another, it's called malicious package. In my code, do I have malicious package? When you click here, you can see this echo power. It allows the remote access. How you can remediate it? Basically uninstall. You can see all this information right there in your infrastructure. You can also see there is a secret detection is there. So for containers, if you have API keys, access token has been exposed, it will show up here. You can see which file has it, where it's located, what does it mean. All this information is right on your fingertips. Then we have services. So we are using, let's say, Envoy, right? And for Envoy, what happens is if it's an upstream connection, it do not verify TLS for peer certificates, right? What does it mean, right? So it tells you how it's risky, right? It also tells you how you can fix it. So basically, you need to do upstream TLS context true, right? So this is where every upstream connection that you have is basically being secured. Then we have application scanners. And this is where what we are looking is, let's say you are using Node.js, and in Node.js, Express.js is one of the known one package management or basically NPM package that doesn't do enforcement on TLS for all your web communication. So how you can protect it, right? So you can see here, you can go to use HTTPS modules to create your web servers. So this is how you can kind of see or understand what are the best practices, or how we can write a code which is more secure. Then malicious, and this is where you can see in your Python, it gives access to your sensitive files, right? how it's affect us. So basically there is a package called site package, and this is allows us what are the passwords that we have exposed it, right? What should I do? Exactly, right? It says remove this malicious package. So things like that is there for you to understand. For Terraform, if you have misconfigurations or if you have sensitive data kind of exposed, you can go to this Terraform, and this is where we are looking at this infrastructure as a code, scanning capabilities, and this is where we can see here, right? So all the authorization is not enforced for all your API gateways, and you can see about how you should protect them as well. So it's not just detecting issues, but it's also telling you the remediation, which is very super helpful for your developers to kind of go and fix it. All right? Questions? Sure.
And just now when you present about the intelligence plugin, so when we scan the code, that all of the scanning is happening locally, or the code
That
needs
is-
to be transferred to your
That is correct. So basically when you do a build, it downloads all the dependencies, and this is where, because your remote repositories or local repositories are being scanned by X-ray, you can see those scan results right there.
Right.
So it's basically doing a local build on your machine, and it shows the results.
I see. So that like there are no have like code need to transfer to your server, right? Like that.
So there is no upload happen.
Yeah.
Yes, there is no upload happen. It's always download happen. Your upload is always happening through your build pipeline. So this is where, when we talk about security, we are not talking about finding CVEs and all that, but we are also talking about who has the access to those pipelines, right? Because your developers might not need read and write access to Untitled, they might need just read only. Because who needs the write access? It's just your CI server and maybe your platform or SRE team. Maybe they are doing overrides or something. They might need write access, but rest, pretty much runtimes, customers, developers, they need read only.
And the second question is like, so let's say if the company decides to use JFrog for our like record. So actually, I never got a chance to use JFrog before. So we use some kind of scan before, but not JFrog. So I don't know like whether you support have a GitHub, GitLab, how it happen.
So when you say triggering a scan from version control, so we do support from for GitHub, GitLab, and GitHub.
Okay. Okay.
Other questions? Sure.
How is JFrog getting access to the Terraform remote state?
So
Like, yeah, an example. Yeah.
yeah, so basically the way it works, so in our factory we have Terraform template supports, right? So there are two repository types has been identified or kind of introduced recently. So if you are storing something in our factory, you can actually do a Terraform scan on those Terraform templates.
Also, like the actual modules you use internally.
Modules, Farooq, do you know? I don't think we have module support for now.
No,
Terraform
no,
modules, right? Yeah.
no.
Thank you.
Any other questions? Good.
Yeah, so how many of you guys are actually using Artifactory at the moment? Almost everyone. And what about X-Ray? Are you guys also using it this time?
Yes.
Yeah, so that's what, in fact, when I speak to some of our customers, that's one thing I realize. A lot of them have access to everything, but they're just using the Artifactory, they're using other tools for security.
Right.
If there's anything we can do to kind of help you guys get enabled, we're happy to support. Conduct those enablement sessions or whatever is required. Basically, two ways I think it benefits. One is X-Ray is a product that's evolved. We recently acquired a company called Vdo. And we did a lot of integration with our existing platform, and it's an extremely capable tool at the moment.
So the research team that I spoke about are all video folks, and we used to say, well, we do the scanning, we will let other people to do the findings. You know this great quote from the 6 element, if you want something to be done, do it yourself. that was kind of our understanding after a while, that if you want a first class results of protecting your software, we cannot say, well, someone else will do the findings and we will do only the scanning. So now we do both. And this is why X-Ray now today is one of the strongest security, supply chain security solutions on the market, because we do both the findings, the research, and then we do the scanning, because now we own both parts of the equation. The research and we know about your SBOM because you use Artifactory. So there's really no reason to overlook X-Ray, especially if you already paid for it. Just if you have a question of how it should be used,
Yeah.
that's why we are
Yeah,
here.
it's a very valid point, because these customers, they've been paying for it and never used it. Probably because they didn't find it good enough when they tried it, or they're not even aware of it. Okay, so I would encourage all of you. I'm not sure if you're all connected to your account managers at JFrog. I have a small team. I'll give you my coordinates. I'm happy to support. As I said, if you guys need any enablement for your teams, for yourselves, we can do that. But I think it's extremely capable and adds a lot of value to the overall investment you guys have made in the platform itself. So we're happy to support that.
Yeah, and that's a good point, right? So because of video acquisition, now JFrog is a partner in CNAs, CV number operating. So we find CVs, we let customer know as a 0-day vulnerability, and then later on we publish into database like NVD and all that, right? And this is where our JFrog research team posts this site, right? And this is where you can see here what are the 0-day we found in last few days, couple of days, and which are the malicious package. So you can see the primary focus for us is right now it's on Python and NPM, because that's where we've seen all the cyber attacks are happening most likely. And this is where you can see these are the malicious package we found. We flagged them. There is a blog post on how we can protect ourselves from this supply chain attacks or any kind of attacks, right? And this is where it tells you about pretty much everything, what are the best practices. As Baruch mentioned, there are include, exclude patterns. You can filter, because my first party code, I don't want that request to reach out to a remote repository, things like that, right? So very nice blog post, detailed one, really helpful for customers.
Okay. So if you guys are looking at, scaling your DevOps practice, when it gets to an enterprise class, I think JFrog is a good option. If that's not the case, if it's way smaller, probably there are alternate open source kind of stuff. But as I said, if it's enterprise, I think we can really help you make it work well. Okay, so me and Marshy are here for a couple of days. We're meeting some of our customers. But if you want us to come over to your office or want to have another session to learn more, understand more, we can find some time. We're here till what, Sunday afternoon? Yeah, so we're here till Sunday afternoon. Friday we're not in town, we're in Canberra. Government customers using us, we're meeting them. Otherwise, till Thursday, end of day, if you want us to find some slot, please let us know. We're here to invite you guys.
Are you guys in the DevOps Talks event at all? Any of you? No? Okay. You got it here. You don't need to go to the conference.
Okay, thanks for joining. What else do we have? Anything else you want to talk about?
Yeah, I mean, in case anyone of you guys have questions, we would love to interact with you, learn from you a little more. And yeah, especially, get this opportunity to know, you guys personally, a little more about,